Good morning, students. Today I will do chemical bonding. See, atoms, they are neutral in nature. They contain same number of the electrons and the protons. Protons, they are positive charge and the electrons are the negative charge. Now, there are certain elements which are unreactive in nature, or we say they are very least reactive, such like the noble gases, helium, neon, argon. Now it was found in these unreactive elements, the electronic configuration is very important. They contains their outermost orbit as a stable orbit which contains 8 electrons, or in the case of the helium, it contains only the 2 electrons. See, in the case of the helium, first shell that is completely filled contains 2 electrons, while the other gases, they contains 8 electrons in their outermost orbit, or we say it is octet position. Now for the atoms to get the stability, they combine together to form the molecule or the compound by the rearrangement of the electrons, so that the each atom it acquires the stable configuration. Now when there is a stable configuration between the atoms, a force of attraction is created between the atoms and they combine together to form the molecules. So this is known as the chemical bonding. So chemical bonding is the force of attraction when the two atoms they get the stable configuration, they combine together, that is the force of attraction, is the chemical bonding. Now say electrovalency, if we take the metals and the non-metals, metals they have a tendency to lose the electron and the non-metals they have a tendency to gain the electron. For example, if we talk about sodium, its electron number is 11, configuration is 281. Now this sodium when loses 1 electron, its configuration becomes 28, that is plus 1. Now here 1 electron is lost and the proton is same, so it becomes positive charge, that is known as the cation. Now in the case of the non-metal, they have a tendency to gain the electron. We talk about the chlorine, whose number is 287. It has 7 electrons there out of orbit, and if it takes 1 electron given by the sodium, its configuration will be 288, or we say that its outermost orbit become the octave in nature. Now sodium outermost is octave in nature, chlorine outermost is octave in nature. Here 1 electron increases, it becomes the negative charge. Now here in this case, this cation and the anion, when they join together, a force of attraction between the opposite charge particle and form a compound that is known as sodium chloride. This force of attraction between the opposite charge particle, see here, force of attraction between the opposite charge particle, that is the chemical bonding. Now this is known as the electrovalency. So whenever there is a chemical bonding due to the gain or the loss of the electron, that is known as the electrovalent bond, and the compound formed by these electrovalent, that is known as the electrovalent compounds, and the electron taking part in the electron bond, that is known as the electrovalency. So the electrovalency, that is the force of attraction between the opposite charge particle. So in the case of the metal, they have a tendency to lose the electron, they form the cations, and in the case of the non-metal, they have tendency to gain the electron. They gain the electron, form the anions. Now, force of attraction between the opposite charge particle, they join together, form the compound sodium chloride. This is known as the electrovalent compounds. Now, take another example. Suppose calcium, whose configuration is 2882. That is a metal. If it give out the 2 electrons, it forms 28 plus 2. That is the cation here is third shell become octave in position. Now here is a different case. It uses 2 electrons. Now in this case, either the non-metal should have a tendency to get the 2 electron. Suppose it takes oxygen whose 2 and the 6 configuration. If it takes 2 electrons from the calcium given, it forms the 2 8, that is the -2 configuration. Now here calcium plus 2 and the oxygen -2, they form the calcium oxide. Okay, so here reaction between metal and the non-metal. Now calcium, whose configuration is 282, that loses 2 electron and form the cation plus 2. And the oxygen has 2 6 configuration, that is 6 electron in the second orbit. It gets 2 electrons and form the 2 8, that is anion. Now reaction between the cation and anion, they form the calcium oxide. Now if we take one more example that is very important. Here calcium 2882, when losses